well, first I'll begin by defining what a rainbow is. A rainbow is an optical phenomenon that causes the spectrum of light to appear in the sky, and it's because of the interaction of the sun and the droplets in the Earth's atmosphere. So, well, the first person to wonder how were rainbows formed was Aristotle. He was the first to think that the droplets were the cause of the rainbows. Then the first measurement was made by Roger Bacon, and in fact he calculated, his calculations were really good. And the complete theory was made by Teodorico, and it was corroborated by Descartes. Well, in order to understand this theory, we have to learn what the Snell's law is about. And well, when you have a ray of light going from one medium to another medium, in which they have different, the light has different velocities, then, I don't know, applying Fermat's principle or Huygens principle, you can find this relationship. Okay. Well, this relationship, using the definition of refractive index, that is the ratio between the speed of light in vacuum and in the medium, you can translate this relationship in this relationship. Okay. Taking the refractive index of the Earth to be 1. So in the treatment that comes after this, N is 1.33 for water, but it's taken for the yellow light, because refractive index for red light is less than refractive index for yellow and blue. Okay, so this is a droplet, and here comes the light from the sun, and it refracts into the droplet, and then it reflects. And the primary rainbow is formed when light is refracted here, and the secondary rainbow appears when you have an internal reflection and then a refraction. And the other higher order rainbows comes from multiple internal reflections. Okay, so I'm going to put y equal alpha r, minus alpha r, yeah, where alpha takes values from 0 to 1. And this point, we can calculate to be this, because it's in a circle of radius r. And so the normal interior vector, this one, is this. Okay, so taking the exterior product between this and this, we can find the relationship between this angle and alpha. Okay, this angle gamma is the angle of refraction. So gamma is arcsinus of alpha. Then applying Snell's law and taking the refractive index of water to be 4/3, we find that gamma prime is the arcsinus of 3/4 of alpha. Well, I'm doing all this. Maybe I can skip it, but I want to find the final angle of deflection. I mean, this is this is the incoming rate, and I want to find how, at what angle it is deflected. I mean theta. So taking like, I don't know how to say it. Well, taking relations between similar triangles and Snell's law and all these calculations, I'm putting it, here it is theta, so putting gammas in terms of alphas, we will find that this angle of dispersion is this. So it depends on where the light of the sun strikes the droplet. We want to find that minimum angle. And so taking the derivative equals 0, we find that this angle is 138 degrees. So when light strikes here, it will go back, and it goes like here, and it will have like many angles. There is a critical angle in which light deflects at 138 degrees, and if it strikes at bigger alphas, then it will go back. So the intensity will happen where this minimum angle is. And, well, so if this is 138 degrees, then we have to be at 48 degrees from here is the sun. I mean, it is like there, the droplet, and you are down. You always make a 42 angle degree with the light. And so that's why you see a cone of light, and that's why the rainbow has an arc shape. And, well, so my conclusions are, how are they formed? Well, because of reflection, refraction, and different velocities of light in a medium. Why are they arc-shaped? Because of that minimum deviation angle, which is 138 degrees. And multiple rainbows comes from multiple internal reflections in the droplet. Thank you.
Questions? Yep.
So you had the diagram with the reflection within the droplet, and yeah. So you have the first ray being transmitted after being refracted twice.
Mm-hmm.
Does that form a rainbow too, or why doesn't it? If it doesn't?
This one?
Yeah.
Well, it's because these rainbows, we can see them because there you have a minimum angle, and here this angle goes from 180 degrees to 138, but the minimum is in 138, so there you have an intensity. Here, you don't have that. I mean, you have light in different directions, so there is light coming out, but you can't see like that intensity that forms the rainbow.
Okay.
You mentioned something about multiple rainbows. Are there actually higher orders than a second rainbow that can be seen?
Well,
is there enough intensity?
Some people say that they have seen multiple rainbows, but it's hard to see them. I don't know the conditions that you need for it. You have to have the sun in the right position because, for example, if you're standing here and the sun is higher, you need to have droplets like near the ground to see the rainbow. And usually we don't have droplets there because they evaporate. So I don't know if there is a relationship between that.
So I guess the amount of moisture in the air matters a lot.
Yeah.
So maybe if there's a lot of moisture in the air.
Oh, okay. You can have multiple rainbows.
Multiple rainbows. I'm pretty sure I've seen it.
Mm-hmm.
No more questions?
Sorry. Wait. Or you will take my scarf.
I don't mind.